All right. So there is a question here that is emanating from gradient and equation of a straight line. That is a topic in Form 2, marking, that is, whereby we are required to determine the equation of a line that passes through the specified point, and that particular line we are told it has a gradient of 4. So there are so many ways of handling it, but the best method, and of course the quickest method of determining this equation or the equation of a straight line is through making substitutions, appropriate substitutions. Yeah. So we know this one is a straight line, therefore we have that general equation of a straight line, the general format of the equation of a straight line. That is y equals to mx plus c, where y represents the y coordinate, x represents the x coordinate, m here represents the gradient, and c represents the y-intercept. And so when giving the equation of a straight line, usually we give the numerical values of the constants. The constants here are 2, the gradient, that is m, and the y-intercept. These are the constants. And of course, when giving the equation of a straight line, we give the numerical values of these constants. So if we have the value of the gradient and the value of the y-intercept, that is c, then we are good to go. That is to mean we already have the equation of the straight line. So here already we are given the gradient, that is m. So that means what we don't have at the moment for us to have the equation of this line fully is the y-intercept. So our question should be, how then do we get the y-intercept? So we get the y-intercept here through making appropriate substitutions. So now that we're given this point, that is 2, 5, where of course 2 represents the x coordinate and 5 represents the y coordinate, we can make use of this point, the x and the y coordinates, and of course the gradient given, to make substitutions in the general equation of a straight line to end up with the value of the y-intercept. So if we get the value of the y-intercept, and of course we already have the gradient, then of course will be done as far as determining the equation of this line is concerned. So therefore, by making substitution, it means where we have y, we are going to substitute it with 5. Where we have x, we are going to substitute it with 2. And where we have m, we are going to replace it with 4. By so doing, in this particular equation, we will only be left with one unknown. Yeah? And of course, if we have 4 variables, if we have 4 unknowns, given 3 of them, then we'll be able to get the 4th one. And therefore, our y, that is 5, so we're going to have 5 is equal to m, that is 4, so 4 into our x is 2 plus c. So from here, we are going to open these brackets. Of course, opening is done by multiplying it with whatever is outside it. So we're going to have, this is 5, which is of course 4 times 2 is 8 plus c. Now, so we group the like terms together. We collect the like terms together. So that means for us to get c, we need to transfer this a to the other side of the equation so that eventually we are left with c. So remember, if an item has to be transferred from one side of an equation to the other, the sign usually changes. So if it is positive this side, like you can see already 8 here is positive, once it crosses over to the other side, it becomes a minus. And as a result, we're going to have, this is 5 minus 8 equals to c. So 5 minus 8 is giving us negative 3, so negative 3 equals to c. So that is to mean c equals to negative 3. Now, we already have m, and of course we have obtained our c as negative 3. So that is to mean we already have the equation of the straight line. We only need to substitute. So that means y, we don't give the values of the variables, y and x only need to have the values of the constants, like I said earlier. So y equals to our gradient is 4, so we're going to have, this is 4x, and our c is negative 3, so negative 3. So that is the equation of the line that is required. So as you can see, it is actually shorter compared to the one that we usually assume there is an arbitrary point. So for me, this is the best method, and of course, the quickest.